Hi, this is Kim Nelson. This video is going to be about basic surfacing tools in Rhino. I've had a number of students ask for a refresher or just some basic instruction. So I'm going to go through basic lofted surface to begin with, lofted surfaces, or swept surfaces I should say. A sweep is anything that is a result of cross sections or rails. The simplest version of a swept surface is a loft. You can find lofted surface right here. You can find it on the menu right here. Okay, so I'm going to go ahead and create curves to generate these surfaces. I'm going to try and base them on a ring form, generally speaking. Just because that'll make an easier way for jewelry people to visualize it. I'm going to start with creating a ring bore, 17 millimeters, standard size. And I'm going to offset this curve 2 millimeters, 2.5. And I'm going to move it up 0.8. which should give me a distance here at the bottom of 1.7. So I got a 1.7 offset thickness at the bottom. Offsets comes around and gives me 3+ millimeters up here on top. Pretty basic front view for a ring. Now, those of you who have watched my videos or taken classes with me know that I work primarily in the perspective viewport. In order to get view information, I just change C-planes. And I change C-planes regularly and quickly, and I do it via keyboard shortcut. So you will see C-planes changing back and forth pretty regularly as I make this. So to create a loft, we'll start by making a copy of this ring bore curve, starting from 0, and I'll set it out 3 millimeters. And I will mirror this to the other side. 3 is a little much. I will copy this out 2 millimeters. And then mirror. I'll hide this center curve for now. So I'm going to use these 3 curves to create a loft. Whenever you're using curves to make a ring that have anything to do with your ring bore or your outer profile, you want to make sure that the seam is located either at the bottom or the top. The one place you never want it is on the sides. If you're surfacing the entire ring at once, usually you want it at the bottom, unless you're putting a setting in which case you would want to put it at the top. If you're surfacing the ring in 2 stages, like surfacing the top and then surfacing the bottom, put the seam at the bottom while you're surfacing the top, and put the seam at the top while you're surfacing the bottom. Pretty straightforward. So Rhino always likes to put these seams over on the side, so I'm going to move them now. Curve, edit tools, adjust close curve seam, and there it is. I'm going to move them around to the bottom quad for all 3 circles. And now I'm ready to loft. So going to do a loft command. I have 3 rails here to use for my loft. I prefer to select them in order. So select curves to loft, outer rim, profile, inner rim. Hit enter. It's going to ask me for the seam. Now, if you've been hygienic in arranging your curves like I was, your seam will be lined up. If not, you may have a different seam location on each curve. You need to move those seams so they line up in a straight line. Otherwise, you'll get a warped surface. So hit enter when you're done. And that is the surface that you get. As I have often discussed, when you're modeling, it's important to know how much of the geometry you're creating and how much of it Rhino's creating. The only part of this that I had control over is the ring bore and the outer profile. The actual surfacing, because it's such a simple swept surface, lofts are the simplest swept surface you can do. Rhino's doing all the work here. So I do have some choices here. I can do normal, loose, tight, straight sections, or uniform. I'm usually going to always use normal or straight sections. You have an option for a closed loft. If I pick this option, it will close off the inside. If I uncheck that, it'll allow it to remain open. These choices, these options here, I really wouldn't mess with at all. So I'm going to take a look at some of the options here, what happens with straight sections. Straight sections will give you this effect. If I hit a closed loft, so it's simply taking and creating a surface with the limited information you gave it to go smoothly between the three curves. And hit OK. Now, a loft is also important to know. If you only have two curves, the only option Rhino has is the straight sections, which I'll demonstrate here. This is actually a very easy way to finish off the inside of a ring, is to pick the two curves of the bore with a loft and hit enter. Make sure your seam is straight and where you want it, and hit enter. You'll see, even though this says normal, it's straight sections. It has to be, because there's no information to do otherwise with. And if I change this to straight sections, it makes no difference. So if you're only using two curves, you'll always get a straight first degree surface between the two curves. That's very helpful to know, because there are times that's exactly what you want. So there you go. Easy way to join these together. And I have a lofted ring shape. Put these back flat here. Pick an easier color for you to follow along with. So now I'm going to do the loft using nothing but cross sections instead of rails. Create a curve for the bottom. I will borrow this curve to use it at the sides of the ring. So, transform, orient 3 points. Quad, 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 for quad, quad, quad. And a couple of mistakes there. That didn't do what I expected it to first off, but also I need to put copy equals yes. So, once again, top and bottom quadrant, side quadrant. That's the mistake I made. The equivalent of the top and bottom and side. And you'll notice this is angled because the outer quadrant is right here. I'm going to go ahead and set a C-plane to that and do a non-uniform scale. So. And actually that seems too distorted to me. So rather than use that, I'm going to rotate it flat. And I'll scale it again. Because I want it to match. What I had originally for that. So actually I don't want it to stretch like that. So. Mirror that over. Do the same thing for the top. And I'll just simply scale that straight up. There we go. So now I'm going to use these curves to create my lofted surface. Curve 1, curve 2. Curve 3, curve 4. Want to make sure those seams line up. You see I have one at the bottom outside of the ellipse, whereas the rest are all, this one is on the inside. The rest of them are all on the inside, so I'm going to move this one so that it is also on the inside, and I'm going to flip that. Like so. And you'll see, once again, Rhino is taking those curves, and that's the information I gave it, and it's creating all the surfacing that goes in between. You can see the seam of this closed surface is lining up with those inside seams that I just lined up. To make this look at all like a ring, I need to close that loft. Okay, so now I have a ring that's the same size for the finger bore, has kind of a soft comfort fit going on with it. It's fine. Notice if I set this to straight sections what I get. Going to hit OK. And I'm going to bring back the two curves that I started with. And I want to note that even though I based these cross sections on this curve, you'll see that the Rhino surface doesn't follow it. It doesn't follow the inside one, nor does it follow the outside one, because these curves were not part of the surface. Loft only allows me to choose one curves in one direction, which in this case were the cross sections, and you can see that it's kind of created its own interesting object. Nothing really wrong with it. It's just not a very precise object. And a surface we don't have a lot of control over is fine. These are both very beautiful surfaces. They're both very clean. They're very smooth. Neither is objectionable. I just don't have a lot of control. On this one, I haven't exerted any control over the actual front view, as it were, of the ring. And on this one, I haven't exerted any real control on the cross sections. And that may be just fine. Depends on what you're trying to make with this tool. So now I'm going to create an open curve. And do the same surface. So you can see what happens when you mix closed curves. It's a curve that comes around and touches on itself into a tight closed geometric form, or one that's open, has two open ends. So I'm going to do another lofted surface here. And look what it says in the command line. Unable to loft. Select either open or closed curves, but not both. Okay? This is an important point. Some of your swept surfaces will allow you to combine open and closed curves, but never in the same direction. Or I should say, never in the same direction. And they also doesn't work well. So I suggest that you avoid it. I suggest whenever you're doing a swept surface, you make it in each direction either entirely closed curves or entirely open curves. You will get a more predictable and therefore usable result. So that's the lofted command. Now I'm going to explore the next most complex. Next one up on the ladder is sweep one rail. Other software programs will call that a one rail sweep. One rail means you have the right to use one rail and multiple cross sections, or one cross section if you like. We'll explore both. Doing a one rail sweep, I pick this rail and this section. And I get this. Now you do have options for freeform and road-like. And it didn't make any difference in that direction, but it can sometimes make a difference. I would recommend that until you have a reason to find a way to make a one rail sweep do something different for you, that you just stick with the freeform. It's going to give you the most successful result. Although I feel the obligation to show you what can be different, so yeah, see, that is not what we want. Back to freeform. So that's generally what happens, is when you try and use the road-like option, unless you know specifically what you're after. In this case, it doesn't make any difference. So, just one goes crazy. All right. So, there you go. So, but I can also use multiple cross sections. I noticed in our last surface these ended up being a little small in this direction, so beef them up a little. So now I'm going to do a one rail sweep using the rail in all of the sections. One rail, one section, one section, section, one section. It's asking for that seam again. They're all on the outside of the ellipse. They're all pointing the same direction. So that's fun. I have a choice whether to have it close here or stay open. And okay, and you'll notice this time the seam is on the outside because that's where it was in my curves. Now notice that Rhino has created the surface in between these cross sections. So what's happening between here and here? Between this cross section and this cross section? I have no control over. So this kind of a bulge you see here, that's Rhino's idea. This kind of inward taper between here and the top, also Rhino's idea. Okay, so the side view I don't have any control over really, other than to keep adjusting the cross sections to get something that I like. Okay, that's your one rail sweep. Now this, once again, going to lop open top. And use the same surfacing command. Sorry, one row. Here, 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 here. And once again, select either open or closed, but not both. All right, now, if I open all of them, Rhino will not have a problem. So there we go. And resurface. And that will work fine. Your one rail, your multiple sections, gives you a choice for closed or open. No complaints. Now, obviously, this can't be a piece of metal because, as we've also discussed before, how thick is this? It's 0, 0, 0, 0, 0. Remember that a NURBS surface is always a rectangle, and it's basically a rectangle of rubber that's infinitely thin and infinitely flexible. So you would have to do a thickness on this for it to actually be printable or usable as a piece of jewelry. Also notice that because these curves are mathematical ellipses, which means they are second degree curves, that Rhino decided to create a poly surface from them. You never want a poly surface unless there's a corner involved you're trying to preserve, or unless it's part of your modeling strategy. Sometimes you need more than one surface, so you plan it out. But accidental like that is a very bad thing. To prevent that, I would rebuild all of these. I always like to have an odd number of points to preserve symmetry from side to side. 15 should work. And now, if I do the same same surface command, this should have been, at this point, a closed surface with it as a single surface. And yet, now it's made it into 3 surfaces. This is very interesting because all of these are single curve segments. They even all have the same math. So now I will rebuild the other curve involved because it's also a second degree curve. It's an arc or a circle. So 36 is a good number for circles. And I will do a 1 rail sweep once again. And yet, it still wants to make that 3 surfaces. There's no reason Rhino should want to do that anymore. These are all, except for it's just deciding that it doesn't like how tight that curvature is. And because it's an open curve. If it were a closed curve, it wouldn't do it. It's trying to hold on to this curvature, and by doing so, it's inserting kinks. That is 4th degree. That is 4th degree. So, here's something that I actually can't explain for you because it shouldn't happen. That should be able to create a single surface. We'll remember this. We'll come back to it because it will be useful. For another exercise later on. Actually, I would like to go back and return our profile curves. I think I have them hidden on another layer, but this is just as fast. Okay, so I will hide those. The next surface up in complexity is the bi-rail sweep. The bi-rail sweep allows you to have 2 rails and an infinite number of cross sections within reason. So I'm going to create a taper on this shank. Something reasonable. Drawing my 2D curves, because all curves you draw in Rhino are 2D curves. And then I'm going to use a curve from 2 views command to generate my 3-dimensional curve. And again. There. So, no longer need these. These will be my 3 rails. Now I need to make cross sections to go with them. Easily done. First I have to make sure they have the seam in the right place. Yes, they do. There. I'll draw the top and bottom cross sections first. straight line down through that ring bore, straight line back from the profile, and into a blend curve. That's fine. Actually, the fastest way to get this is to just do an intersect. Sorry, a section command. There we go. Line straight into the finger bore. Line straight back from the ring bore. Blend curve again. Quick way to give a soft shoulder to something. And mirror it over. And join it. And mirror this across. And do that top. Straight back from the top of the profile. Blend curve. Actually, I'd like to have a knife edge up here, so I'm going to redo this and then hold the shift key down and pull back. Enjoy. So I have what I need. Now, I need to understand what I have here. I have 3 circles. These are second degree curvature curves. I have 4 polycurves. Each one of these is 2. Left and right, front and back, I should say. If I explode them, you'll see 4 curves, 8 segments. So I'm going to expect that whatever surface I create will have a seam down the middle. I would like to tell you that Rhino's completely predictable on this front, but it's not. So I can't choose this rail. I can only choose this rail and this rail. I can only have 2. And here are my cross sections. You have some choices here. Close sweep, we're familiar with. Maintain height, we are not familiar with. Maintain height gives you a rigidity in like the normal direction or from the surface. It maintains height between cross sections so that you get a cleaner, more rigid looking surface. You do have an option in this command to add more slashes if you need them. If you feel like your surface could use the benefit of a slash, you can put that wherever you want between your 2 rails. You can skew it, which will change the whole grain of your surface, for example, which you shouldn't do. But you can. I'm going to see if Rhino created a seam. It did not. Rhino forgave the fact that we had polycurves. There was a time when Rhino would not have forgiven that. It has become much more user-friendly. So I'm going to go back and create that properly without messing with the... That's a nice surface. Gave me good control over that side view. Gave me reasonable control over the front view. Notice what's happened. I'll go to a straight on front. See how this is not following along that curve? That's because we only have the two rails. We can't exert full control over the form of this. But still a nice surface. I want to show you something about curve math here. I'm going to divide this curve up. By creating a small channel down each side here, like so. So that is a highly ornate or evolved cross-section. Rhino will accept it because it's still, they're all open curves. Rhino has nothing to really reject this for. It's just going to interpret what happens in between them because we don't have any additional cross-sections. So between here and here and here and here, Rhino will be coming up with the information all on its own. But Rhino does a beautiful job of coming up with information, so it should be okay. And there we go. Fades out to smooth on top, fades out to smooth on the bottom, and then does this lovely graduated channel. Very nice. Once again, it's not going to really follow the front view because we don't have cross sections in here to fill this out. Rhino's inventing them. But as Rhino normally does, did a lovely job. The thing I want you to notice is the new math of this surface. Composition of the surface, I should say. This curve is 1, 2, 3, 4, 5 segments long. Actually, this is 2 pieces. So it's actually 1, 2, 3, 4, 5, 6 pieces. Rhino has to always base the surface on the most complicated curve in the cross sections or in the network of curves that you're using. Since these are the most complicated curves, the whole surface will inherit their math. And here we have one surface, 2 surfaces, 3 surfaces, because that's an arc that I used. Rhino's actually making it a 2 split surface. It decided since this was fairly straight across, it could interpret that as a single surface. So we have 1, 2, 3, 4, 5, 6, 7. 7 surfaces to create that object. All right. Important lesson is if you have an advanced polycurve somewhere in your model, you're going to have an advanced surface resulting from the entire sweep. The sweep inherits the DNA from those curves, and that you don't have complete predictability. Rhino is going to decide that some of those curves need more than one surface, and others that are actually split between 2 curves can be justified or handled with just one surface. What you need to know is what you've ended up with. Always look at your model and know. A fast way to know what this is to explode it and read the command history, or the command line. exploded a poly surface into 7. Okay? Then you can undo. So you know what this is, because if you're trying to model on this later, you need to know how many strips of surfacing you're dealing with. And this brings us to the most advanced surfacing tool in Rhino. As far as sweeps go, this is a surface from network of curves. Surface from network of curves allows you to use as many rails and as many cross sections as you like to get what you want. Okay? The caveat to that is the name of the surfacing tool. Surface from network of curves, never surfaces. Your surface from network of curves command can never give you a poly surface. This is a wonderful thing most of the time, because most of the time you don't want a poly surface. Okay? So here we go. 1, 2, 3 rails. 1, 2, 3, 4 cross sections. Enter, and Rhino is good. Pretty nice. However, it's all one surface. So this crispness that you have here is gone. Okay? It can't be there because in order to make a true corner, you need 2 surfaces. And this command can only do a single surface. If I explode this, it cannot explode a single surface. So it's a wonderful thing, unless you want to maintain hard, sharp corners, in which case you need a poly surface, in which case you need to sweep in separate steps. To get what you want. Okay. This, by the way, I've kept this around because remember, Rhino was giving us arbitrarily 2 surfaces for this. Actually, it was giving us 3. With surface from curve network, Rhino would not be allowed to do that. And Rhino can work with just 1 rail and multiple cross sections. Okay, it made a liar out of me. It says no, I can't use that because it's basically too simple. Yeah, never mind. If Rhino were willing to make the surface with this few curves, it would have made a single surface. It's not going to play. Okay. So, those are your sweeps. In sequence of sophistication. Loft, 1 rail, bi-rail, surface from curve network. The last thing to consider with all of these surfaces is the question of tangency. So, I'm going to put all of our surfaces on a common layer. And turn that layer off. And come back to our rails that we have here. Put one of these flat again. setting that back up. So I am going to create a surface in here on the inside of this. And I'm actually going to mirror this over. It's going to be easier for me. If I mirror, and then rebuild, and then turn on some control points. Grab the center two rows here. Move them back. And move them back. And now I'm going to create a patch surface to fill this. Throw away the curve. Mirror it over. Now when I create my lofted surface from this, it will read the edges of these surfaces and make sure that whatever it creates remains smooth to those surfaces. Loft. Edge. Profile curve. Edge. Which is not where I would like it. So. And here it's going to give me choices. I can match the start tangent. And you'll see how that's puffed that out to pick up the directional information from this surface. I can hit match start tangent. And by doing that, join those completely together and hit EMAT. You will see that Rhino has taken that directionality to create a smooth transition. This idea of being able to take information from surfaces and not just curves is important. The one rail sweep does not allow it. The bi-rail sweep does. So does the surface and curve network, as does loft. So that's an important thing to keep in mind when you're modeling. Do you want to create continuity with another surface? Because if you do, it can be very helpful. Going to ungroup these. And I will explode these cross sections. Remove half of each one. Join it back together. I'm going to create a situation here. record history, and I will do a loft. Actually, I want 3 curves, and I'm going to do a loft. So I want a smooth, kind of curvy surface. And with 2 surfaces, as we just discussed, all I'm going to get is a first degree straight cross-section surface. There we go. Record history, loft. And we're fine. Now this looks straight because all these curves are the same, but if I take this last one here, and I scale it, I can get a swoop on that. And actually, I would like to swoop both of these. Going to reloft that because I'm going for a specific form I want. History again. Loft. And I'll scale this one. There we go. Okay. A lot of effort just to set this up, but there we have it. So, now I have a surface coming into these curves. Surface from Curve Network. Actually, we'll do it with Biro Sweep. Surface edge. You can't read it unless you select the surface edge as your rail. Sections. Close sweep. And in this case, it isn't going to allow me to do what I would like to do because it will only allow you to do this on sections for a bi-rail sweep, not the rails. It'll allow it on the sections. And which is a little frustrating. You see it's blacked out. It still creates a crazy looking thing, but not the crazy looking thing I would like. So I'm going to try and do the same thing with reversing the direction. I'll pick this rail, and this rail, and this cross section, and this cross section. And it will not allow me still. Okay. Probably because they're poly curves. I'd like to tell you I had a good answer for why. Generally, in one direction or the other, a bi-rail sweep will let you read. Let's find out one. Actually, I don't want to leave that hanging. Use a single curve. Rail. Rail. And it still won't allow it. Let's try it for surface edge, curve, and just use the simple cross sections. now they will allow it. So it comes down to a question of math. If the math becomes too difficult, Rhino will just say no. And those poly curves here at the sides presented a big challenge for the software. So it just said no. So it's the Rails that will allow you to do it. And there we have it. And you'll see that it did maintain. Smoothness. Now when it did that, maintaining the smoothness, it pulled the surface away from the curves a little bit. Had to, in order to give you that surface smoothness that you were looking for. The last example will be the surface and curve network. Because it can only create a single surface, it will tolerate these very sophisticated polycurve cross sections. It just won't obey them very well. You'll get a softness, as we saw earlier. But there it is. It'll allow you the tangency. In fact, it'll allow you curvature. The difference between tangency and curvature is curvature will push 2 control points into the surface worth of press, and tangency only does 1. So it doesn't reach as far into the surface with its influence. But it'll reach all the way in. And maintain that smoothness. So always be aware that you have the option to use surface edges as your rails. And I would recommend that you normally think of it in terms of rails, but Surface and Curve Network will allow you to take surface information from rails or curves without a problem. So, so that surface tangency information is a consideration that you can take into mind when you're working with the suite. So, these are the objects we made. So, this is the easier color to see. Multiple swept surface approaches to creating ring forms. It is worth noting, just because I don't think I did at the time, that this surface from curve network solution, the ring does follow the profile, unlike this sweep from 2 rails where this sunk in, because you can use that profile curve as part of the sweep. You can do a very accurate job. Surface from curve network gives you the most control. Therefore, it creates the most opportunities for unsmooth or lumpy or unhappy surfacing, because you are more in control than the computer is, or have taken a considerable amount of control. The only drawback to these, besides the fact you've got to be careful making them because it's your hand that will show at the end, is that you can only get a single surface. You can't get a poly surface. Okay? That's it for this video on swept surfaces. Thanks for watching.